I want to do one more example of writing a vector in terms of its x and y components, in terms of just one single vector. We'll have more examples where we're adding vectors together, but just one more basic intro example. So here we have the position of an object is 18 meters, I should say, away from some sort of origin, and at an angle of 52 degrees south of west. So again, the 18 meters is what we call the magnitude. The angle is what we call the direction. Now, south of west, whenever we deal with a problem that has north, south, east, west, we superimpose that north, south, east, west on our typical Cartesian coordinate system. Typically, we say north is the positive y direction, south is the negative y direction. That would make east here the positive x and west here the negative x. So this is our typical setup of a problem that deals with south and west here. So when they tell us the position of an object is 18 meters away at this angle, south of west means if you start west and head south by 52 degrees, this is where our vector lies. The length of the vector represents 18 meters, and then the angle we know is down below that 52 degrees. I'm just going to draw it again to the side and draw in my x components. I know I have to travel to the left and then down to start at the same place and end up at the same place. I know the hypotenuse is 18 meters long. I know this angle is 52 degrees. Whenever we have the length of the hypotenuse, the magnitude, and an angle, then sine, cosine, that's going to come in handy. When we say the cosine of 52 degrees is the adjacent side. In this particular triangle, the adjacent side to the 52 is the x side, so our x component, divided by the 18 meters. If I solve for x, I get x is 18 times the cosine of 52. I'm getting 11 meters. Now I do need to recognize from my picture that this points left. I drew my arrow here to the left. To start at the same location and only move horizontally, I have to go left first and then down. That will be important when we write out our vector in terms of vector notation. To find the y side that's adjacent our 52, and sorry, it's opposite. So the sine of 52 degrees is the y side, the opposite side, over the 18 meters. So the y side will have a length of 18 times the sine of 52. So a length of 14, but we had to travel down to represent that completely. So this vector we would write as negative 11 I hat minus 14 j hat meters. Negative 11 simply means go left by 11, and where you just ended, go down by 14, and we will end up where we started. So trig, setting up these right triangles makes it easy, it makes it easier to look at and figure out which side is x, which side is y, figure out the hypotenuse and angle just based off of the information given. So from here, we're going to start looking at adding vectors, subtracting vectors, because we're still going to look at motion, and motion still involves position, velocity, acceleration, which of course are all vectors. So that's what we'll look at next.